Africa is increasingly positioned as a future cornerstone of the global green hydrogen economy. The logic behind this narrative appears straightforward. The continent hosts some of the world's strongest solar and wind resources, vast tracts of land suitable for large-scale renewable deployment, and geographic proximity to major demand centers such as Europe and the Middle East. On paper, Africa looks uniquely suited to produce green hydrogen at globally competitive costs. The African Green Hydrogen Report. Potential to power. Advancing green hydrogen. Across Africa takes a more grounded view. It does not dispute Africa's technical potential, but it challenges the assumption that potential alone guarantees success. The report's central argument is that green hydrogen is not constrained by technology availability, but by execution capability. Africa's opportunity exists, but it is conditional on system integration, infrastructure readiness, financing realism, and institutional coordination. Rather than framing hydrogen as a singular energy solution, the report treats it as an industrial system. Hydrogen only becomes viable when power generation, water supply, electrolysis, storage, transport, offtake, and finance operate together under real-world constraints. Weakness in any one element undermines the entire project. In Africa's case, this interdependence is magnified by existing infrastructure gaps, higher capital costs, and competing development priorities. One of the report's most important clarifications is the distinction between theoretical cost and delivered cost. Africa's renewable energy resources can achieve very low levelized costs of electricity. However, hydrogen is not electricity. Each kilogram of hydrogen incorporates conversion losses, compression or liquefaction costs, storage requirements, transport logistics, and financing expenses. When these are included, the headline advantage of cheap renewable power narrows significantly. Cheap electrons do not automatically produce cheap molecules. The report emphasizes that Africa's early hydrogen market will likely be export-oriented. Domestic hydrogen demand remains limited to specific industrial uses, such as fertilizer production, refining, and niche heavy industry. Export markets, particularly Europe, are currently driving interest through policy targets and import strategies. While this creates opportunity, it also raises the bar for execution. Export-oriented hydrogen projects require ports, shipping infrastructure, storage terminals, and regulatory alignment that often exceed current capacity. Infrastructure, rather than electrolyzer availability, emerges as the primary bottleneck. Many proposed projects assume that ports can be expanded, grids can be stabilized, water can be sourced, and logistics can be financed, often without clear commitments or timelines. The report repeatedly highlights that hydrogen projects do not fail because electrolyzers do not work. They fail because infrastructure arrives late, costs escalate, or utilization drops below economic thresholds. The current project landscape across Africa reflects this challenge. The report identifies a growing pipeline of hydrogen and hydrogen derivative projects across North Africa, Southern Africa, and select coastal regions. Yet very few projects have reached final investment decision. Most remain in pre-feasibility, feasibility, or memorandum stages. This gap between announcements and investment is not unique to Africa, but it is amplified by higher perceived risk and financing costs. Water availability is another critical constraint addressed directly in the report. Hydrogen production requires significant quantities of purified water. In coastal regions, desalination provides a technical solution, but adds capital cost, operational complexity, and energy demand. Inland projects face more sensitive trade-offs, particularly in arid regions where water scarcity already affects agriculture and communities. The report stresses that water governance must be integrated from the outset to avoid social conflict and long-term viability risks. Financing conditions are central to the report's analysis. Green hydrogen projects are capital-intensive and long-dated, with returns sensitive to utilization, power pricing, and offtake certainty. In many African markets, the cost of capital remains substantially higher than in Europe or East Asia. Even modest increases in financing cost can overwhelm advantages gained from low renewable energy prices. This reality shifts the focus toward risk mitigation rather than pure cost optimization. The report advocates for targeted public intervention, not blanket subsidies. Blended finance, concessional capital, guarantees, and public investment in shared infrastructure are highlighted as mechanisms to reduce specific risks that private capital cannot absorb alone. The objective is to crowd in private investment by lowering uncertainty, not to replace it. Poorly structured subsidies, the report warns, can distort incentives and delay the emergence of competitive projects. Policy alignment is another recurring theme. Several African countries have published hydrogen strategies, signaling intent and ambition. However, strategy documents alone do not deliver projects. Hydrogen development intersects with power regulation, water law, land access, industrial policy, environmental permitting, and trade frameworks. Misalignment between these domains often causes delays that erode investor confidence. Clear, predictable, and coordinated policy environments are essential for bankability. The report also cautions against assuming automatic domestic value creation. Hydrogen projects do not inherently generate broad-based economic benefits. Without deliberate policy choices, much of the value may accrue to external equipment suppliers, financiers, or off-takers. The report recommends linking hydrogen production to domestic industrial clusters where feasible, such as fertilizer manufacturing or green metals, to anchor demand and skills locally. Institutional capacity and skills development receive significant attention. Hydrogen projects demand expertise across engineering, finance, environmental assessment, operations, and negotiation. Many African countries face shortages in these areas, particularly at the scale required for large projects. Capacity gaps increase reliance on external advisors, lengthen project timelines, and raise costs. The report emphasizes training, institutional strengthening, and knowledge transfer as foundational investments rather than optional add-ons. A critical warning throughout the report concerns overpromising. Hydrogen has become politically attractive, often framed as a transformative solution capable of delivering exports, jobs, and decarbonization simultaneously. The report urges restraint in public messaging. Inflated expectations can lead to rushed project selection, weak structuring, and eventual backlash when outcomes fall short. A phased, realistic approach is presented as more credible and ultimately more successful. From a systems perspective, utilization emerges as a decisive variable. Hydrogen economics are highly sensitive to how consistently electrolyzers operate. Intermittent renewable supply, grid instability, maintenance downtime, or logistical bottlenecks can reduce utilization and sharply increase unit costs. Designing systems that manage variability through storage, grid access, or hybrid power solutions is essential. Optimizing individual assets in isolation is insufficient. The report's recommendations reflect this systems logic. It promotes corridor and hub-based planning rather than isolated projects. Hydrogen hubs that co-locate power generation, electrolysis, storage, and export infrastructure can reduce duplication, improve utilization, and lower costs. Shared infrastructure spreads risk and improves resilience. However, hubs require coordination across agencies, long-term planning horizons, and political consistency. Regional cooperation is also emphasized. Hydrogen supply chains will not align neatly with national borders. Harmonized standards, coordinated export strategies, and cross-border infrastructure can enhance Africa's collective competitiveness. Initiatives such as the Africa Green Hydrogen Alliance are highlighted as mechanisms to align policy and share best practices. Fragmentation, by contrast, risks slowing development and weakening negotiating power. Timing is another subtle but important dimension. Africa's hydrogen opportunity is not unlimited in duration. Other regions are moving quickly to secure market share, lock in offtake agreements, and establish standards. Early movers may shape the market. However, speed without readiness carries its own risks. The report advocates for strategic pacing, advancing projects that are genuinely ready while allowing others to mature rather than forcing premature investment decisions. Demand certainty remains a challenge. Hydrogen projects require long-term offtake agreements to secure financing, yet many buyers remain cautious, waiting for prices to fall or regulatory clarity to improve. This creates a chicken and egg problem. The report suggests that public procurement, pilot contracts, and international partnerships can help bridge this gap in early phases, creating reference projects that reduce perceived risk. Environmental and social considerations are treated as integral to bankability. Hydrogen projects can have significant land, water, and community impacts if poorly planned. Early stakeholder engagement, transparent benefit sharing, and robust environmental assessment are essential. Projects that neglect social license often face delays, legal challenges, or cancellation. In this sense, community acceptance is framed as an economic variable, not a secondary concern. Taken together, the report presents green hydrogen as neither a silver bullet nor a speculative gamble. It is a complex industrial system with real potential and real risks. Africa's advantage lies in resource endowment, but success depends on disciplined execution. The projects that succeed will prioritize integration over scale, realism over rhetoric, and system performance over headline capacity. This brings the report to its most practical implication. Execution capability is now the limiting factor. Many projects fail not because the idea is flawed, but because teams underestimate how quickly complexity compounds once multiple systems must operate together. Hydrogen exposes weak links mercilessly. A technically sound project can still fail economically if utilization drops, infrastructure is delayed, or financing assumptions collapse under scrutiny. Bridging this execution gap requires more than ambition. It requires structured understanding of how hydrogen systems behave in reality. This is where execution-focused platforms such as H2 Hub by Renewable Energy become relevant. H2 Hub is designed to address the same challenges identified in this report: system integration, utilization risk, infrastructure sequencing, and bankability, by focusing on how projects move from concept to final investment decision under real constraints. However, understanding system risk is only part of execution. The other part is financial translation. Hydrogen projects ultimately succeed or fail on numbers. Cost assumptions, utilization rates, infrastructure dependencies, and financing terms must be modeled transparently. Financial models force assumptions into the open and reveal whether a project survives stress. For this reason, disciplined project finance modeling is essential. Professional-grade green hydrogen and clean energy financial models allow teams to test sensitivity to power pricing, capital cost escalation, utilization variability, and financing structure. These tools are not marketing exercises. They are decision frameworks that align technical ambition with financial reality, enabling credible discussions with investors, lenders, and public stakeholders. Used together, execution-focused learning platforms and rigorous financial modeling address the core challenge identified by the African Green Hydrogen Report: the gap between theoretical potential and deliverable reality. They help prevent the most common failure pattern: strong announcements followed by prolonged stagnation before final investment decision. The report's final message is clear. Africa does not need to win the hydrogen race by building the largest electrolyzers or announcing the biggest numbers. It needs to win by building systems that work. Systems that operate consistently, finance cleanly, and integrate responsibly with local infrastructure and communities. Africa can indeed become a meaningful green hydrogen producer. But that outcome will be written not in strategy documents, but in projects that reach operation and survive stress. Hydrogen rewards discipline. It penalizes shortcuts. The opportunity exists, but only for systems built to carry the load.